So here we go. So this is what we get. So there's a bunch of problems with it, but at the very least we can say it is technically working. We're spawning new rigid bodies into the sim, which is something we haven't done before. We usually just start, of course, from just having a pre-fractured set and then running things from there. So that definitely works, and it's very helpful that we are not having these tight bundles collide on the first few frames, because we do see them colliding later on. You can see how evenly spaced this stuff is, though, and that's because their collision holes are huge. These are very small pieces with very large collision holes. Similarly, we can see lots of things rolling all the time. These pieces are probably too big, or they're definitely too big in general. Lots of stuff, lots of room for improvement. So let's go down here. I'm going to disable the sim so that we can, still scrub the cache. Let's just look at let's look at some frame. Try to choose a frame that doesn't have too many pieces when we click. We're going to click over to this bullet data thing here. Click show guide geometry. It'll take a little bit, even on a nice computer, to visualize those collision holes for some reason. So press W to go in the wireframe, and you can see really big collision holes around each of these pieces. Also, they're pretty round, and that's what happens when you peek out. Basically, when you push out from a small object like that, it just kind of becomes like a round thing. So that's why things are being held away from each other, and that's why things are rolling. So let's start with that. So here's frame 10, or I guess frame 11. What's the first frame that we see anybody on? Turn this off. Okay, so this is fine. We'll just go with this one. So show guide geometry. Let's actually turn the sim off, because changing the hull on this will count as, re-simming it essentially. So now that we're down in here, let's say going down to 0 right off the bat. Oh. Going down to 0 will get us a pretty tight fit on this. I'm losing the camera there. So press W, and you can see it's much tighter now around each of these pieces. I'm actually going to go here and bring my camera real up close to it. Cool. So that looks, pretty good, and that will go a long way towards it having a better collision. Now, the collision padding is not inherently a bad thing. It's just that collision padding will help with collisions, like resting collisions and stacked collisions, but it also makes those, much bigger. Like if I put a 1 on here or something crazy, you'll get insane, it just makes collision holes that don't really make any sense. Also, I'm going to move this over to the pre-solve, because I remember from before, we're supposed to have rigids on frame 10. I guess we should also just say solve on creation frame. There we go. We didn't even need to do that. Okay, so make sure you put solve on creation frame to get that 10th frame there, that very first one. Anyway, too big. Drop it down to... We can go back all the way back down to 0. See what that looks like. Although, we also need to determine our actual sizes that we want in the first place. So this is too big. So let's go up to here, where this is where we're actually instancing our pieces on, and this is where we are determining how big they are. We can probably play around a lot with this, and as I often say, this is where a lot of your, artistry is going to come in, where you're going to be like, this is how many pieces I need, this is how big it should be. 0.1 is clearly been too big, so maybe half that, so something like that. It feels better to me. Maybe these should actually be, these should probably be a little bigger. Like the smallest one should be bigger, The biggest one should be smaller. That's probably pretty good. And, you know, and I always like to have only a few of these at the end being actually the full size. So position 1 and 1, and then maybe come back a little bit, like around here, maybe even all the way back to 0.9. That should be like all the way down to like the half level or something. Then by the time we get all the way down to like 0.7 over here, that's when it should really have dropped off by now. And this can be something like that. And then the bottom one, it's probably okay. So we get a nice distribution of pieces. Big enough that we can see, and it was worth our while actually simulating them as rigids, because of course everything else is just going to be the points that we do in the particle simulation anyway. So that's good. It at least felt like they spun fine. I think these numbers were okay. Let's come back into here again. We can see the new collision holes are all there. We're still, just spoiler alert, we're still going to get a situation where, because these are convex hulls, they're always going to kind of want to rotate, like just continue to roll a little bit. We can fight that back a little bit by saying maybe they shouldn't bounce as much, because right now they're bouncing a lot. Let's do something like half that. Oops. And I'm going to do it on the ground thing too for superstition's sake. We can also go straight to the rigid body solver itself and say, well, seeing as we're using the parallel constraint solver, we can just throw a whole bunch more substeps at it to get more accurate solves. We can also say, hey, if you stop moving for even a little bit of time, 0.2 seconds, which will be like 4 frames, then just stop entirely. Just go to sleep. That'll help. Even literally putting a pop drag, a particle based, basically a per point drag for some amount. This we will probably have to play with, but I usually start with 0.01. It's pretty sensitive. So this will just remove energy from the simulation and just slows things down, arbitrarily. And then it'll also, kind of like with the particle sim, it'll also feel nice that it rushes out and then slows down. So that's a whole bunch of stuff. So let's see what that looks like. And I'll kill the old one, and let's see. Oh, I left the wireframe and the collision hulls on. So I'm just going to close that. W to come back out of that. And let's turn off Show Guide Geometry. Okay, save and view the flipbook.